I'm Chrissy Hammond. I'm a scientific researcher here at the University of Bristol. I mostly work on zebrafish and how they can model skeletal diseases. My department specialises in neuroscience as one branch of it, and the other is like kind of physiology. So how do the different organ systems in your body work? My work fits into musculoskeletal stuff, so I'm really interested in how musculoskeletal diseases occur. How do the cells sense their environment? So how do they understand like genes, aging, mechanics? And I'm really interested in understanding how disease processes occur.
So my name's Nicola and I'm a postdoc researcher here at the University of Bristol. And we're trying to understand how tissues are built. So in your tissue, you've got cells, you've got water, and you've got like a protein scaffold. And so we're trying to look at how these cells are building that scaffold that they then get to live on. So in your bones, you're going to need a really strong load-bearing scaffold. And then sort of in your skin, you need a really stretchy one so you can flex. The big study as an extended team that we have that's really important is discovering that this sort of scaffold that I've been talking about, this extracellular matrix, seems to be being built and repaired with a circadian rhythm and a body clock, and that's forming the basis of all of our research at the moment.
I mean, my passion is being able to watch stuff happen. I use zebrafish as an animal model, so we spent a lot of time showing that really the way that we look at things in zebrafish reflects the way that disease processes happen in humans. So that means we can pick apart the very earliest stages of disease, at stages where things might be treatable.
This is a really poorly studied area, but we think the body clock is probably underlying a lot of different disease pathologies. So we know that sort of as aging, your clock dampens and you don't have a very strong body clock, and this can accelerate the aging process.
Your cells do things in relation to when your central body clock is, because that's the time when they're most useful. So for example, a lot of the healing and repair that goes on in your body goes on when you're asleep. And we know that people who are shift workers, for example, have different incidences of different diseases, and they can include cancer, but it can also be things like repair, like skin repair, fracture repair. And we know that things like your central body clock changes at different points in life. And we're really interested in understanding why that's the case and what that should mean for how we treat different conditions.
So we know that your pattern changes as you go through life. So children tend to sleep earlier and longer. Teenagers do naturally biologically go to bed later and wake up later. And then much older people tend to sort of sleep shorter and again much earlier. And we know that your body clock is dysregulated as you're older, and especially when you've got other complicating diseases like Alzheimer's and Parkinson's. But day to day and during other more complex diseases, we don't know what's going on and whether this is a way we can help people.
It's really important because it can give us different ways to treat diseases. So partly to just understand them, but we're starting to understand that chronobiology is a really important factor. So for example, if you get an injury at a different time of day, your healing response might be different. And if you take medications at different times of day, it can have an impact on how effective they are. So if we can start to understand that better, we can therefore develop better treatments with the tools we've already got available.
So it'd be good to know when people have noticed a phase of their life that their sleep pattern has changed. So whether they're going to bed earlier or later, or waking up earlier or later. It would help us hone in on where we need to focus our studies and what's important to the public.
What we're really interested in is just getting a broader feel for what happens at different points in people's lives and why those changes to sleep but also their central body clock changes. So the more we understand about what people experience, the better and more representative we can make our research.